All right, we're going to be going over solving higher order equations today. We're going to be using some of the skills that we've been working on over the past couple of class periods to do that, like solving these higher order equations like we were last class. Also thinking about end behavior and sketching graphs based off that information. And then I'm going to show you guys how to use graphing calculator or graphing calculator website like Desmos to find the solutions to these equations. And then I'll show you how to use the graphing calculators in class next time I see you in person. All right, so let's think about what we were doing last class in order to solve an equation like this. So we want to think about how we're going to factor this polynomial over here on the left-hand side. And so what method we're going to use. Since there's 4 terms, we want to think along the lines of using factoring by grouping. So I'm going to go ahead and split the problem in half and then think about what's in common here in these first 2 terms. And those both have an x squared. And so I'm going to bring x squared out, and then that division there leaves me with an x, and this division here leaves me with a minus 3. And then what do these 2 have in common? Since x and 3 don't have anything in common, so we can just take out a 1. But since the x is negative, we want to take out a negative 1. So I bring down that negative 1, and then negative x divided by negative 1 is x, and positive 3 divided by negative 1 is negative 3, and that's equals to 0. So just double check, our sets of parentheses are the same, so we can continue factoring. This is x squared minus 1 times x minus 3 equals 0. And of course, we still have a little bit more to do because this is a difference of squares here. So I'm going to use my difference of squares factoring to set up 2 sets of parentheses, one with a plus sign in the middle and one with a minus sign. And then where does x squared come from? From x times x. And where does 1 come from? From 1 times 1. And then our x minus 3 needs to drop down. And our equals 0. All right, so now it's all factored, and so we set each factor equal to 0. X plus 1 equals 0. X minus 1 equals 0. And then x minus 3 equals 0. And of course, those are easy equations to solve, so we know x is negative 1, x is positive 1, and x is 3, or positive 3. So there's our solutions. So we got 3 answers, just like we knew we would, because that highest exponent is a 3. We know that was telling us that we should get 3 answers. So let's take that and transition down to thinking about what we did on the test to, what's the end behavior of this function. If we think back just a second ago, our leading coefficient is 1, which is a positive number. And our degree was 3, which is an odd number. An odd positive, or a cube, just like we talked about, it should look like an n. And so that means that our end behavior could be described as x goes right, then y goes on the right side of our graph is going up, and then as x goes left, y goes, what's the left side of our graph doing? It's going down. All right. So we have our solutions, we have our end behavior. What we want to think about is, what do those solutions also represent on the graph? And I think I talked with you guys, most of you guys, about this yesterday or during block day. But remember, a solution is also known as a 0, or a root, or an x-intercept. All 4 of these terms are related. And what we're going to be looking at today is mainly that this idea is that they are also x-intercepts. So we can take that idea that we just found the x-intercepts by finding the solutions and just kind of sketch that out. So if I think that one of my x-intercepts is at -1, and the other one's at +1, another one's at 3. So wherever you think those numbers are, just putting those on your coordinate plane here. And then think about what our end behavior tells us about the graph. It says that our left end is supposed to point down, our right end is supposed to point up, and also that idea that this graph should look like an N. So the left end starts down, and it loops smoothly through from -1 to +1, and then it'll loop smoothly through 3. So just kind of getting an idea of what that graph would look like. The heights of these bumps could be higher or lower than what we sketched, but we just kind of get a general idea of what this graph should look like. So when we go to actually use the graphing calculator, we should be expecting to see something like this. So let's look at Desmos.com. And type in my function, so x cubed, let's see, minus 3x squared, oops. Minus x and plus 3. Alright, and so as we look at the function as it graphed, we see it looks pretty much like what we said. The left end is going down, the right end is pointing up. Here we can see that it's crossing at -1, 1, and 3. And so you can use Desmos. It's very user friendly. Just notice all I had to do was click on the graph at those points, and it tells me where they are. So this is how you're going to use your graphing calculator eventually, and I'll show you how to use that technology specifically. But what you guys can be doing for your assignment and while we're in class here today is just using Desmos. And all you have to do is click on those points, and it'll tell you where they are. Like here, if I want to know what the y-intercept was, I could click there. Or here, it's telling you where one of those, what we might consider to be a vertex would be. Tells you those coordinates. So, and what we're interested in here is the x-intercepts. So -1, 0, 1, 0, and 3, 0. Alright, and so that's the end of that example. See you on the next one.